On the 3rd of August, Alibaba announced a 2.4 trillion parameter flagship. For the next 11 days, the people who actually run models locally ignored it and talked about a 27 billion parameter model that didn't exist yet. On the 14th, it shipped. The model card says they were right, and it contains one fact about how this thing is built that essentially nobody covered. This is a brief about a prediction that turned out to be checkable. Two models, 11 days apart, from the same lab and the same generation. One got the headlines, the other got the attention of everyone who has to fit a model onto a card they actually own. I want to walk through what shipped, what the model card says, the architectural detail that went almost entirely unreported, and how the community's call held up when the numbers landed. Here's the sequence. On the 3rd of August, Alibaba announced Qwen3.8 max 2.4 trillion parameters, a sparse mixture of experts model. On the 13th, its open weights arrived, but text only, stripped of the vision and long context features that made the hosted product interesting, and under a bespoke license with revenue share obligations rather than a standard open one. Then on the 14th, the 27B shipped, dense, clean, Apache 2.0, and natively multimodal. The flagship got the press cycle. The small one got 2 weeks of anticipation from people who read model cards. So what actually landed? 27 billion parameters, dense, meaning every one of them activates on every token with no expert routing. Apache 2.0, weights open, commercial use permitted, no asterisks. Native vision language, it understands images and video as a first-class modality rather than through a bolted-on adapter. A native context window of 262,144 tokens, extensible toward 1 million with ERN scaling, and it is aimed squarely at the 24 gigabyte consumer card. That last one is the whole reason this release matters more than the flagship. Now here's the part I think got missed. Qwen3.8-27B is not a conventional transformer. The card gives the layer stack in a single line, 64 layers, arranged as 16 repetitions of 3 gated DeltaNet blocks, followed by 1 gated attention block, each with a feed-forward network after it. Read that carefully. 3 linear attention blocks for every 1 full attention block. It is stated plainly on the model card, and essentially no coverage I reviewed mentioned it at all. It is not trivia. It is the explanation for everything else on the spec sheet. Why does that ratio buy you anything? Standard self-attention compares every token to every other token, so cost scales with the square of the sequence length in compute, and more importantly for a local user, in the key value cache that has to sit in video memory. That quadratic term is the reason long context has historically been a data center feature. Linear attention variants like DeltaNet trade exactness for a recurrent style state that scales linearly with length. They're cheap, they hold long-range information adequately, but on their own they lose the sharp associative recall that full attention gives you. Heap 1 full attention block in 4, and you pay a fraction of the memory for most of the capability. That trade is what moves a 250,000 token context from a server rack onto a desk. There's a second architectural point worth being precise about, because it's the one people get backwards. The 27B is dense, all its parameters fire on every pass. The max is sparse, 2.4 trillion total, with only a fraction active per token. Sparsity sounds like it should help you run it. It doesn't. A data center operator holds the whole model in aggregate memory and pays only the active compute, which is a superb trade for them. A local user has to hold every expert in memory regardless of how few of them fire. That's 4.9 terabytes at full precision, and still around 397 gigabytes on an aggressively quantized 1-bit build. Sparse helps the host, dense helps you. On to results. The 4 numbers that traveled through the coverage were SWE-bench Pro at 61.7, Qwen SWE-bench at 79, Live Code Bench version 6 at 90.3, and GPQA Diamond at 89.2. I checked all 4 against the model card and every one is exact, which is worth saying out loud because it is not the usual outcome. 2 more that didn't travel, Terminal Bench 2.1 at 73 and Humanity's Last Exam at 30.8. That last figure is the useful reality check. This is a 27 billion parameter model and HLE is nowhere near solved at this size. And here is the omission that bothers me most. Every write-up called Native Vision the surprise of this release and then quoted only text benchmarks. The card publishes 4 vision language results. OS World Verified 84.3, Android World 81.9, Web Arena Verified 64.8. OS World and Android World are computer use and phone use agent benchmarks. The model driving a real desktop and a real Android environment from screenshots and completing tasks. Scores in the 80s on those from an Apache licensed model that runs on a single consumer GPU is the most consequential thing on this card. It got the least attention of anything on it. Which brings us to the comparison the community set up in advance. On the 10th of August, Meta released Muse Glimmer, a 30 billion parameter dense open weight model under Apache 2.0, built for agentic work sized for one consumer GPU. Well received, and a commenter said it might be the strongest agentic model of its size. Quote, for like 3 days before they released Qwen. That was a joke about release cadence. 4 days later, it was a measurement. Same tier, same license, same target card. On SWE-bench Pro, the one benchmark both publish 51.2 against 61.7, a 10.5 point gap in favor of the model with 3 billion fewer parameters that also happens to see. So how good was the call? On the 3rd of August, the day the Max was announced, the read was that benchmark legitimacy comes from the flagship, but practical deployment would come from the 27BA, that it was where the real adoption wave would land. On the 6th, one newsletter put it more bluntly, the Max is a great video and a bad daily driver, while the dense 27B, runnable by anyone with 24 to 32 gigabytes of GPU memory, was the story worth caring about. On the 13th, a developer newsletter made the practical case in storage terms. Every one of those claims was specific enough to be wrong. And the scoring key. Apache 2.0 in genuinely open, correct, and pointedly so, given the flagship's weights went out text only under a bespoke license. 24 to 32 gigabytes, locally runnable, correct, that's exactly the class the card targets. Dense rather than mixture of experts, correct. The adoption wave claim is unresolved, and the only honest verdict this early, adoption is measured in months, not days. And there's one clear miss. Nobody called the native vision. It arrived as a surprise, and it brought the computer use scores with it. The useful lesson isn't that a newsletter was right about a model. It's that the signal was available 11 days before the artifact to anyone reasoning from architecture and hardware constraints instead of press releases. The full written file has the complete benchmark table, the architecture worked through in detail, the head-to-head, and the sources behind all of it. Every figure in this brief comes from the model card, linked in the description alongside the full written file. Thanks for watching.